All right, welcome to section 2.6. We're going to graph tangent of x, and we know tangent of x is sine of x over cosine of x. So the coordinates that I want here are all the 1, 0s, and 0, 1s, those right there, and I want the pi over 4s because the values are the same, and since we're dividing, that's going to create 1s and negative 1s. So those are the ones we want. So at negative pi, count to here, 0 over negative 1 is 0. Negative 3 pi over 4. Negative over a negative is a positive 1. 0, negative 1. Negative 1 over 0, that's undefined. At negative pi over 4, same 2, so that's a 1, but because there's one negative, it'll be a negative 1. At 0 radians, 0 over 1. Y coordinate over x coordinate. Pi over 4, they're both the same, so that's a 1. Pi over 2, 1 over 0, whoops, that's undefined. 3 pi over 4, x and y are the same except one's negative, so that's negative 1. And my pi is the same as negative pi, we're back to 0. So the undefineds go in as vertical asymptotes. So vertical asymptote, and now we have 3 points in between our vertical asymptotes. We have an x-intercept right in the middle, so we'll always go halfway between the asymptote lines. Upper half, cut it in half, pi over 4, you're at 1. Lower half, cut it in half, negative pi over 4, you're at negative 1. And we draw our curve. And we'll go 1 period length of pi to 3 pi over 2, put in another vertical asymptote, copy those points in, redraw my curve. Over at negative pi over 2, we'll go pi to the left and negative 3 pi over 2. Again, x-intercept in the middle, half of the upper half, 1, half of the lower half, negative 1, draw your curve. My domain is going to be all these vertical asymptotes thrown out. So x cannot be equal to any pi over 2 times a odd integer. Negative 3, negative 1, 1, 3. So you can write that as x cannot equal pi over 2 times the binomial 2n minus 1, or it could be 2n plus 1. They are interchangeable parts. My range, all real numbers. So my characteristics, looking at these graphs in your notes, the graph is not continuous at your multiples of pi over 2 and has vertical asymptotes at these values. The x-intercepts, they're all at some n times pi, where n is your integer. 0 pi, if you will. 1 pi, 2 pi, negative 1 pi, negative 2 pi. The period length is now pi units apart. So now your formula for p is not 2 pi over b, but just pi over b. There are no minimum and max values, so there will be no amplitude, but you still need the a value to help you find the first and third points. That's where you have the y coordinate of negative 1 and the y coordinate of 1. So that just means whatever your a is, you multiply it to that negative 1 and 1. The graph is symmetric with respect to the origin. It's an odd function, and which means that tangent of negative x is equal to negative tangent of x. All right, steps for graphing tangent in our transformation form. Each iteration of the graph is made up of the 2 asymptotes and the 3 key points in between. That iteration means 1 period length. With no translations, plot the center point at the origin, like we did. But if we have translations, the center will be at C and D. This is where we shift left and right, up and down. Calculating your period using our formula, P equals pi over B, where you will go out half the period to the left and half to the right of the origin and draw on your asymptote lines. Midway between the center point and the asymptote lines, this is where we're going to go top half up to 1a, down to the left bottom half, down to negative a. All right. Your tangent graphs are increasing without a reflection. If I have to flip it over the y-axis or over the x-axis, then it's going to become decreasing. All right, then we just create additional iterations, which means additional periods by drawing all the asymptotes and points a distance of p away in any direction. All right, so let's graph y equals tangent of 1/2 x. So b is a half, so I'm going to take care of the period length right away. So p divided by a half is going to be 2 pi. Asymptote lines, okay, now wait a minute. I changed my period length. Normally they had negative pi over 2 and pi over 2. My origin stays. So now, because I have a period of 2 pi, my asymptote lines, they're going to go to negative pi over 2. Excuse me, negative pi and positive pi. Here's my center. Half the period length to the left, half the period length to the right. There's my vertical asymptotes. Then if you want, we'll go 2 pi past this over to 3 pi, put in another asymptote line. So here we are at our center. And, oops, wait a minute, I got to put the equation of the asymptote lines. They are always some negative number being multiplied to pi. So that's 2n, again, plus 1 or minus 1. They're interchangeable, times pi. My a value is 1, but I don't have an asymptote. So upper half, center to right asymptote, halfway, we'll go to 1. Lower half, cut it in half, negative pi over 2, go down to negative 1, and we'll draw in our curve. And we'll do the same thing over here. X-intercept in the middle, upper right half, up 1, lower left half, down 1. And draw in your curve. Now, if we put the half on the outside, now that's your a value. That's going to affect these y coordinates where they're out of 1. All right, and here's my tube in the middle, so that I get a period length change, pi divided by 2. All right, using that formula here, but now we divide by 2. All right, so if my center is at the origin, and my period length is pi over 2, all right, half of that is pi over 4 to the right, pi over 4 to the left. There's my asymptote lines. So we could draw in some more asymptote lines, and then we'll draw in our 3 sets of points. So now this point, half of the upper half, up to 1, oops, not up to 1, we got to multiply the 1 by a half, so that's going to come down to a half. And half of the bottom left side will go down a half and draw our curve. And then we'll do the same thing in between each set of asymptote lines. There we go. So my asymptote lines are now at a pi over 4, 3 pi over 4. So again, it's an odd integer being multiplied to pi over 4. So 2n plus 1, that binomial times pi over 4 again. The a value was a half that we're using for those y coordinates of 1 and negative 1. All right, graphing reflections. Well, reciprocal functions, I should say, not reflections, but reciprocal functions. Cotangent is the reciprocal of tangent. Now, we're going to go through these values and we're going to create the cotangents right away. Okay, now, take all the reciprocals of these answers. So 0 over 1, I flip that, that's 1 over 0, that's undefined. You flip 1 over 1, that's still 1. 1 over 0, well, that becomes 0 over 1, that's a 0. I see a pattern. Every 0 becomes undefined. Every undefined becomes a 0. The ones and negative ones, if you flip them, they don't change. Negative 1, undefined, 1, that's a 0. Negative 1, that's undefined. So now I have vertical asymptotes at all my n pi's. Negative 1 pi, 0 pi, 1 pi. So I'll come over here, here's 0 to pi. Now, in between, let's go between these two asymptote lines. Just like tangent, in between, in the middle, is an x-intercept. Now the upper half, cut it in half, I don't go up to 1, I go down to negative 1. And the lower left half, we go up to 1. And here's my curve. So tangent curves are increasing throughout its entire period length. Cotangents are going to be decreasing. So if we want to put in another asymptote line over here, x-intercept in the middle, lower half up at halfway, we go up to 1. Right half, cut it in half, down to negative 1, draw in our curve. All right, same rules apply for cotangent as it was tangent on one condition. It's the location of your asymptote lines. So instead of being at normally negative pi over 2 and pi over 2, we're now going to be at 0 and pi. And instead of increasing, it's going to be decreasing. Everything else stays the same. So example 2, if we're going to graph y equals 1/2 cotangent of x, here's your b. Pi divided by 2 is pi over 2. My asymptote lines, all right, I shortened it. Usually it was 0 to pi. I shortened that to now 0 to pi over 2. My a value is 1/2, so that's going to affect my 1s. So 0 for n, that's 0 pi over 2, that's a 0. 1 pi over 2, 2 pi over 2. We'll have another vertical asymptote here. So in the middle, put in your x-intercept. Lower half, cut it in half, go up to 1. Oops, not up to 1. I got to multiply 1 by 1/2, so down to 1/2. Upper half, cut it in half, down to a negative 1/2. Draw in your curve. We can put in another period here. Point, point, point. Draw your curve. And we can do one over here. We can repeat it. Put in another one. So if they tell you to fill in the graph, we'll just copy them over. If they said just one period length, you just need from the 0 to pi over 2. Okay, y equals negative 1 is my a. Cotangent of 1/2 x, so b is 1/2. So that's going to give me a period length of 2 pi. So now I'll start at 0, and instead of going out to pi, we're going to go over to 2 pi. So that's going to be 0 to 2 pi, 4 pi, 6 pi, all even numbers. So that's 2n pi for my asymptote lines. And my a is a negative 1. So between my two asymptote lines, we're going to plot our x-intercept. And then we're going to multiply negative 1 to all our y-coordinates. So lower half, cut it in half, go up to 1, oop, check, check, multiply by negative 1, we're at negative 1 right here. Upper half, we go down, whoops, we don't go down. Now we're at negative 1, we're going to multiply by negative 1, that's going to take us up to a positive 1. There's my curve. All right, at negative 2 pi, we'll put in another asymptote line, x-intercept in the middle, and follow the pattern of our points and draw in another iteration, if you will. Example 3, practice with shifts. All right, so find y equals tangent of x plus pi over 4. Well, the first thing I do is I look at my graphs and say, wait a minute. This isn't even a tangent curve. It has to be continuous in between my asymptote lines. So we're going to throw that out. It's not even a tangent curve. Okay, these two are tangent curves. They're looking good. Okay, what I want to do is say, well, normally we start at the origin, but x plus pi over 4 tells me I need to shift to the left pi over 4, and looks like this one went up instead of left, so this isn't it. This one has to be the correct answer. All right, B, graph negative 1 plus cotangent of x. Okay, cotangent of x is decreasing between their, come back here, all right? So since it decreases, I'm saying, well, check out this curve, increasing, increasing, B, increasing, increasing. I'm going to say we're going to throw these two out They're not even cotangent curves. Okay, decreasing, decreasing, good. Decreasing, decreasing, C or D. Now, normally we're starting on the x-intercept halfway in between, but we have a negative or minus 1 here. That means we have to shift down. Well, this graph looks like it's shifted up. This one looks like it's shifted down. So I'm thinking this one's not going to work. This one's my correct answer. And there's our tangent curves.